Okay, hi everyone. So we're moving on from non-linear graphs today. We're looking at functions, which is related to graphs, but we're not going to be focusing on the link between functions and graphs. We're going to be focusing on the algebra side of functions. So first thing, substitution is going to be really important for today. So we've got a starter on substitution. So pause the video now. I want you to have a go at these four. If you're feeling very confident with substitution already, you don't have to do this. But I would recommend maybe having a go at one of them just to check that you're happy with it before you move on. So pause the video now, have a go. I'll put the answer up in a sec. I'll go through the first one, but I'm not going to go through all of them. Okay, so here we've got the answers. So for this first one, I'll go through that one. So v equals minus 11, find 8v minus 10. So we've got v as minus 11, so 8v is 8 times minus 11. So that gives us minus 88. And then on top of that, we've got minus 10. So minus 88 minus 10, that gives us minus 98. So that is our answer for that one. And then the others, similar method, you're substituting in whatever the algebraic symbol is into wherever it is in the expression. Okay, so functions. What is a function? So you will have heard probably of function machines before. And that's what this is. It's basically you've got an input, something happens to it, and then you've got your output. So you probably will have seen these as number machines, maybe not since primary school though. So basically, we've got this new notation for it. So basically what this is, there's f here, that's the name of the function. So it basically tells us, it doesn't really give us that much information about what the function is. It's just a letter. You'll usually see it as f, but if f's been used, they'll switch to g. But f's the most common one for it. But in theory, it could be any letter. Then in the bracket, you've got this x. That is the input. So looking at the diagram at the top, you've got the x. That's what's going into the function. So we say this first bit on the left-hand side, f of x, or function of x. And it tells us x is the input, f is the function. So in this case, f of x equals 2x. That is because the output of the function is 2x. So it's saying a function of x is 2x. So this is saying if I was to put x into the function, this is what would come out. So it basically is a way of explaining what the function is. So we're going to see some examples. So don't worry if you're a little bit lost, it will become clearer as we do some examples. So let's have a look at this first one. This is our first actual example. So what does the function do? So let's have a look. So we put in x. So x is what's going in. So looking at the whole of the outcome over here, what are we doing to x? So let's look. So the first thing that's happening to x is it's getting squared. So we square it. Square x. And then, so squared x, so we've done that, then we add 2. So we square x, then add 2. And that's all we need to say. This is what the function does. Whatever you put in, so x, you square it, and then add 2. So basically, this is the input. The output is whatever the input was squared plus 2. It's just slightly different notation than what you will have seen before. So it's the same idea as a function machine. You can see we've got step 1, step 2 of the function machine, but it's just a different notation. It's a bit more useful than function machines because you can do harder questions using this. So what is f of 3? So we've done question 1, f of 3. So what that means is if the input was 3, what is our function going to be? So f of 3 equals, so you can see in our example up here, this is f of x. So whatever's up, and we can see that we've got x squared plus 2 on the right. So our function, if we've got f of 3, what that's going to be is everywhere where there was an x on the right hand side, our input's now 3. So we're going to swap the x's for 3's now. So we've got 3 squared plus 2. So you can see we've swapped the x as we've swapped x and 3 in the input section here. So we also swap x and 3 in the output section. So we've got 3 squared plus 2, so 9 plus 2. So that is 11. So if 3 is our input, 11 will be our output. So let's have a go with a slightly trickier one. So we've done this one, we've got 11 as our answer, f of minus 5. So now we can see again, we don't have x as the input, we've got minus 5 as the input. So looking back at our function, if we had x squared plus 2, we now have minus 5 squared plus 2. So I'm going to put the minus 5 in brackets to make it clear. So minus 5 squared plus 2, and you've got to be really careful with functions. If you've got a negative and it's squared, you've got to square a negative number, so it's a negative times a negative. So minus 5 times minus 5, that is 25, positive because it's a negative times a negative. And we've got 25 plus 2. So 25 plus 2 is just 27. So f of minus 5 equals 27. Okay, and this is actually quite similar to what we were doing before in last lesson with tables. Basically, you're substituting in a value into this expression. So you've got x squared plus 2, you're just substituting in 3, and you're substituting in minus 5 is what we've done so far. So very similar to when we were doing a table of values last lesson. Okay, last one, a little bit trickier. So we've got f of a equals 38. So what we're told here, we're actually told the outcome, but not the input. So we're told the output, but not the input. So we need to work that out. So what we're going to do is we're going to write out f of a in terms of a. So we know that f of x is x squared plus 2. So f of a, we've swapped the x for the a, so we're going to rewrite that in terms of a as well. So we've got a squared plus 2. So we've got what f of a is. So we know a squared plus 2 is f of a. So we know that f of a is 38. So we know that a squared plus 2 equals 38. Because we've got f of a here. So we know that a squared plus 2 is equal to f of a. We know from the question that 38 is equal to it. So we can say a squared plus 2 equals 38. So now we just need to rearrange to get a squared. So we're going to minus 2 from both sides. So we get a squared equals 36. And from that, that tells us a is either plus or minus 6, because square root of 36 could be plus or minus 6. I think for a question like this, at GCSE you would need to put plus or minus, but at year 9 level you'd be fine if you just put 6. So don't worry too much about plus or minus. So we've done that one as well. So the key for this one is that we're given the output, and we had to work out what the input was. So it's kind of working backwards. So a little bit trickier. We are going to do another example of this. But if you're feeling confident, feel free to have a go at some of the questions. If you're feeling like you'll benefit from the other example, stick around for that one. So we've got f of x is square root of x minus 2. So we've got a square root in this one, so it's a little bit different. The idea is very similar. So what does this function do? So we can see we've got x minus 2, and then we square root it. So we subtract 2, then square root. And you can tell it's that order because this is inside the square root. So we do the minus 2 first, then square root. So you can see again like a function machine, step 1, step 2. What is f of 3? So we know that f of x equals square root of x minus 2. When we've got f of 3, you can see that we've swapped the input from x to 3. So that means we're going to swap it on our output as well. So we've got 3 minus 2. So 3 minus 2 is just 1, so we've got square root of 1, which is just 1. So f of 3 is just 1. So I've done that one. So now let's have a go. So again, this one's like the last question on the first section. We've got f of a equals 11. What is a? So we need to work out the input now. So let's write out, so we've got our formula bit, f of x equals square root of x minus 2. So this is just what we're given as the function. So if f of a equals 11, so we've got f of a, so if we've swapped x for a there, we need to see that in the answer as well. So we've got f of a equals square root of a minus 2. So we've got square root of a minus 2, and we're told that that equals 11. So let's write that out now. So square root of a minus 2, that equals 11. So the key thing is we've got two different ways of seeing f of a. We've got it here, and we also know that f of a is equal to 11. So we've got square root of a minus 2 equals 11. We need to solve for a because we're looking for the input a. So we square both sides. So I'll just do that as like a box with a 2 to show squaring. So squaring it, so we've got a minus 2, that equals 121. And last step, add 2. Because we've got a minus 2, we want just a, add 2, so 123. So we've worked out what our input would be to give the output of 11. Okay, so last one, this is just the very last sort of question, so one last example where we're going backwards from the output. So if we know that f of x is x minus 3 squared, we know then that f of a is a minus 3 squared. So all we're doing is swapping x for a. So just switching out on the input and the output. So we've got f of a equals a minus 3 squared. And we're told that f of a equals 0. So we're told that a minus 3 squared equals 0. So if we're told that, we need to now work out what a is. So we're going to square root on both sides because we're trying to solve to work out what a is. So square root both sides to get a minus 3 equals 0. And then to get a on its own, we're going to add 3 to both sides. So we just end up with a equals 3. And you can check that. So if we substitute in a equals 3, we've got 3 minus 3, which is just 0. So that does work. So we've got a minus 3, a equals 3 as our answer, as the input one. So that's all the examples for today. I will attach an extra video as well, just because I think it's a bit of an unusual topic, so all the examples you can get are beneficial. If you are a bit stuck, watch them first, but if you're very stuck, feel free to email and I should be able to help. The task today is on Dr. Frost. If you do find that quite straightforward, which you may do, there's an extension task here as well. So it's just the first 3 questions on the right hand side here. Sorry, the 3 questions on the right hand side here. So have a go at that if you have got plenty of time and you want a bit more challenge. We're going to be carrying on with this tomorrow as well, but getting a little bit more advanced. So make sure if you are a bit stuck on this, you do drop me an email and let me know. And the answers to the extension questions are here as well.